What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to look at lesson 1.4, distance, and we're going to be able to talk about how do we find the length of just a line segment on a number line, and then we're also going to find the distance between 2 points on the coordinate plane. Both kind of go along with the lesson we talked about yesterday with line segments, so make sure you give that one a try. Let's go and get started with our first definition. So our first definition is, well, what is distance? So distance is going to be measured between 2 points. And it's going to be the length of the segment between those 2 points. When we talk about distance, we always want to talk about it in a positive number. So we're also going to talk about absolute value and how to find that as well, okay? A picture of that could be just a segment like this. Let's name our segment PQ. And really all you're going to be doing is finding the difference between those. So you can do P minus Q, but find the absolute value of that, or you can even do Q minus P. So if you take, like, for instance, let me get a new number. Let me say that P is number 1 and Q is number 7. I can do 1 minus 7 or 7 minus 1, but both of their absolute values would still give me 6, so the distance would be 6 of that, okay? So we're going to think about number lines here because we're actually going to use some first. So let's go ahead and make sure this is copied down, and then we'll move right along to talk about these. Now these are going to be very simple. You can either count up or count down, but I would like you to start thinking about using absolute value to find your distance. So for instance, if I wanted to find the distance of CF, C is at -1, and I'm going to subtract that by letter F, which is at 5. Now -1 minus 5 is -6, but the absolute value of -6 is +6. I could check that just by looking at my number line and just counting my hops. 1, 2, 3, 4, 5, 6. Either one of those ways work, but I do want you to get used to subtracting because we're going to see that in just a little bit with the distance formula. Let's go ahead and pause, and maybe you try A, D, and C all on your own, and then play it when you're ready to check. All right, so AD you could do -4 minus 2, and that'll still give you -6 as your absolute value. Final answer would be 6. And then C to E, we should have gotten 4. -1 minus 3 is -4, but then absolute value of -4 is +4, okay? Next up, determine whether CB and DF are congruent. Go ahead and pause the video here, decide what you think, and then we'll check it. All right, from C to B, we're looking like we have 2 units. I can even test that out. -1 minus -3. Notice if I have a double negative, that actually means plus a positive, and this is proving why we add 2 negatives together. So -1 is a distance between that and -3 is actually 2 steps. Whereas DF, if I take D and subtract F, 2 minus 5 is -3, or the absolute value is equal to 3. So no, not congruent. I'm going to put a box around that too. Okay, moving right along, go ahead and take your time here and try this one. It says the coordinates of Q and R are -7 and 12. The coordinates of S and T are -3 and 16. Are they congruent? And if they are congruent, what is the length of each segment? All right, let's see how we did. So Q and R, I'm just taking -7, subtracting 12. I'm going to get -19, so their distance is 19. And then we have S and T, -3 and 16. That is also -19, so yes, they are congruent. They are both 19 units long. Okay. Next up, this is the second portion of our notes. Let's go ahead and flip on over. Now we're going to talk about distances on the coordinate plane. We are going to discuss the distance formula, but in just a moment, let's go ahead and talk about how to do what I need with that. First thing we want to know is 2 points can be represented by this: x1, y1, and then x2 and y2. Okay, that just means I have one set of x's that can be a pair, and one set of y's that can also be a pair, the distance formula, we're going to be able to use those two coordinates and plug it in to this formula. Square root of, so that'll be your final step, x2 minus x1, and we'll square that, plus y2 minus y1, and square that, okay? Let's go ahead and take time to pause the video here, make sure you've gotten everything copied down. We're going to try example 4 together, and then you'll try example 5 on your own. So let's go ahead and try the example 4. What I'm going to do first is I'm going to go ahead and label my x1, y1, x2, y2. x1, y1, x2, y2. The next thing I'm going to do is I'm going to plug it back into my formula. So the square root of x2 minus x1, I want you to be careful here because x2 is 3 minus x1 negative 2. So I want you to write out 3 minus negative 2. That's super important because there's a double negative which is going to change the whole entire ballgame of that. And then my y2 minus y1, 7 minus 5. So I'm squaring that. 3 minus negative 2 actually means 3 plus 2, and that's going to give me 5. So I'm going to do 5 squared plus 2 squared. 5 squared is 25, 2 squared is 4, and 25 plus 4 is 29. So I need to find the square root of 29. It is an irrational number, so that's about equal to, let's round it to the nearest tenth, 5.4 units. Okay? Go ahead and try example 5. Again, you might see a double negative here. Pause the video if you need to go back and look at your distance formula to plug it in. When you're ready to check it, click play. All right, first things first, x1, y1, x2, y2. So I'm going to do square root of 2 minus 4, and then plus y2 minus y1, 9 minus negative 3, squaring that. 2 minus 4 is negative 2. 9 minus negative 3 is 9 plus 3, which is 12. Negative 2 squared is positive 4, because that's negative 2 times negative 2. 12 squared is 144. 4 plus 144 is 148. And then I take the square root of that irrational number. I'm going to get about 12.2 units. Hopefully you did okay there. Some other questions I always get, Ms. Mullins, is it okay if I do x1 minus x2 and y1 minus y2? Yes, you can do that. Just make sure that if you start with x1 and do minus x2, you have to start with y1 and do minus y2. Other than that, thanks for tuning in. We'll hope to catch you next time when we learn a little bit more about midpoints and bisectors. Have a great day.